Hello everyone and welcome to another math tutorial video. This time we will be adding and subtracting radical expressions, which is on IXL 9. So the directions say to subtract and write in simplest form. A little bit different from multiplication or division, but it's not really that bad. We're going to use a lot of the same skills. So we are going to start with -9 on the square root of 3 minus 10 on the square root of 3. Okay, so this one's actually pretty easy because if you notice, we have a common factor on both of these. I have square root of 3 here and square root of 3 there. So our GCF equals square root of 3. So if that is the case, then I can just go ahead and combine. So I have -9 square root of 3's, and then I'm going down 10 more square root of 3's. So in total, we're going to have -19 times the square root of 3. So that we're using that good old greatest common factor skill that, just keeps on popping up. Learned that a long time ago. We'll just keep using it. So that's really not too bad, is it? But if we look at the next example, it gets a little bit tougher. On this one, notice I have 3 times the square root of 80 minus 2 times the square root of 5. So I don't have a greatest common factor here because 80 and 5 are completely different. Here, we had the exact same thing. I had square root of 3 on both. And this one, I don't have that. So we want to break this down so that I can actually do some kind of combination. So we're just going to bring down the 3. So I have 3 on the square root of, we need to break down that 80. There actually is a perfect square inside of 80. So if you think of your perfect squares, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Well, 16 actually goes into 80. So if I were to divide 80 by all these perfect squares, I know that 4 goes in 80 as well, but 4 is not the biggest perfect square that goes in it. But if I do 16 times 5, that will give us 80. So, 16 times 5, and then I'm going to be taking away 2 on the square root of 5. I can't really do anything on that part. So, 16 is a perfect square, so I'm going to circle it because I know it's going to come out. So, I'm going to have 3 times 4, the square root of 16 is 4, and then all of that is going to be times, my heavens, what is this doing? Times the square root of 5. And then we're still taking away minus 2 on the square root of 5. Notice, now we have square root of 5 on both of those. So we actually will be able to do some combining in just a moment. But first, 3 times 4 gives us 12. So I have 12 on the square root of 5, and then we're taking away 2 on the square root of 5. So 12 square root of 5's, taking away 2 square root of 5's, that's going to give me 10 on the square root of 5. And that's really all we can do there. Okay, so let's look at the next example. So on this one, we have negative square root of 72 minus 9 on the square root of 2. So once again, we don't have that greatest common factor. We cannot combine it. But we can break the square root of 72 down. So let's do that. So I'm going to have negative square root. Okay, so square root of 72. I know that 9 times 8 is 72, but the only problem with that is 8 also has a perfect square in it. I know that 36 times 2 is 72, so it's probably what we're going to use. So let's do 36 times 2. We're not really changing it any. 36 times 2 is a square root of 72, so we really haven't altered the problem. It's still the same thing. And then minus 9 on the square root of 2. Okay, so then square root of 36, that is a perfect square, so I'm going to circle it. Use yellow this time because I think that'll be a little less distracting. So we're going to have negative. Okay, the square root of 36 is 6, so it's going to be a negative 6. And that poor 2 there, it has to stay in because it is not a perfect square. And then minus 9 on the square root of 2. Okay, and Okay, so now I have negative 6 square root of 2's, and then I'm taking away 9 square root of 2, so I'm going down even further. So that means I'm going to be at negative 15. My stylus is acting up. But what else is new? So negative 15 on the square root of 2. Okay, let's do one more. These really aren't that bad. So one more example. So on this one, let's try to do another example. Well, let's say that we have, and this is going to be when you get up into the harder problems. So let's say here we have 4 times the square root of 54. And then we're going to add the square root of 24. Okay, so on this one, neither one of these are in simplest form. We actually need to break them both down. So I know square root of 54. What perfect square could go inside it? Well, 4 won't go in. If you did 54 divided by 4, it wouldn't work. But if you divide it by 9, well, 9 times 6 is 54, and 6 doesn't have a perfect square inside it, so we would be good. So let's do that. So we're going to have 4 and square root, and then we're going to have plus, and then we're going to break both those down. So for 54, we're going to have 9 times 6, and for 24, we could have 4 times 6. Notice both of them are going to end up having that 6. So to circle my perfect squares that are going to end up coming out, the 9 will come out, the 4 will come out. Okay, so as I break this down, this is going to be 4. Well, the square root of 9 is 3, so 4 times 3. And then I still have my square root of 6. The 6 has to stay in there. Plus, well, the square root of 4 is 2. And then we're going to have the square root of 6, which stays in there. So 4 times 3 is 12, so I have 12 square root of 6. This is being silly. So 12 on the square root of 6, whoa. Plus 2 on the square root of 6. 12 plus 2 is 14. And my greatest common factor is 6, so 14. Man, I'll eventually get it. So we have 14 times the square root of 6. All right, so I really think that's good for this lesson. So if you have any questions or concerns, just feel free to message me. Let me know. And